Hi class, this is the pre-recorded video discussion on Module 5. Basically, your Module 5 and 6 are analysis tools for engineering economics. So to start off, we will be having our first part of the analysis tools. So on Module 5, we have division of three topics. No? Number 1 is the worth method. Number 2 is the ratio method. And number 3 is the analysis. So, on this part 1 of the Module 5 discussion, we will be basically discussing on the first breakdown, so the worth method. So, the worth method are broken down into 5 different subtopics. Number 1 is the present worth method. Number 2 is the annuity worth method. Number 3 is the future worth method. Number 4 is the IRR method. And lastly is the ROR method. But to start off, we will be focusing more on why do we need to have single project evaluations. So, in this module, we will be able to understand clearly what is our role when it comes to the industry or when you are future engineers. So, why is there a need for an evaluation, by the way? Number 1 is for profitability. It is to know if the project or investment is profitable. Number 2, acceptable or acceptability. So it is also a means to know if the project or investment is acceptable. Number 3 is the rejection. This is also the reason why we need to know if the project would be either accepted or rejected. And lastly is evaluation. This is to evaluate the values of the investments from time to time. Okay? So, there are different types of evaluation methods. No? For the first part of our discussion, number 1 is what we call as a present worth method. Number 2 is the annual worth method. Number 3 is the future worth method. Number 4 is the rate of return method or the IRR. In other terms, that refers to the internal rate of return. And number 5 is the ROR method, wherein you have to get what is the rate of return of the certain investment on a yearly basis. But let's focus first on our present worth method. NPW, or in other terms, the NPV or the net present value. So it is the present worth criterion, the present worth of all of the cash flows, inflows and outflows. So also it is associated with every investment project. Okay. The difference between inflow and outflow is referred to as a new present worth or the net present worth. This determines whether the project is an acceptable investment. And then NPW is when NPW is positive, this means the project or investment is acceptable. So here are the steps in evaluating the net present worth of a project. First is determine the interest rate that the firm wishes to earn on its investments. And the interest rate determined represents the rate at which the company want to earn in this type of investments. So the value of capital available for lending and investing. So in other terms, they refer it as MARR. They estimate the life of the project or the service life. Number 3, estimate the cash inflow for each period over its service life. And number 4, estimate the cash outflow for each period over the service life. Number 5 is determine the net cash flows for each period. No? And lastly, find the present worth of all cash flows at the MARR. So you might ask what is MARR. I'll be discussing it on the later part. Determine the net present worth of all of the cash flows. So in other terms, what does that mean? Number one step is find the MARR, or what does the company wants for the MARR. It is referred to as the minimum attractive rate of return for any investment that is defined by the company. Number two, how many years is the service life of the project? Number three, what are the benefits of the investment? Number four, what are the costs of the capital investment? Number five, cash inflow is greater than cash outflow or vice versa. Number six, what is the net cash flow? And step seven, if your present worth at a certain interest rate or MARR is greater than zero, that means you have to accept the investment wherein based on your MARR, your benefit outweighs your cost. But if your present worth is zero, you'll have to remain indifferent because at that point in time, you do not have any loss or any profit based on your target na MARR. Lastly, if your present worth is less than zero, rather, you should have rejected the investment. So here is our problem after this one. So the net present worth, that is the net cash flow, equals to the cash inflow minus the cash outflow. Problem number one. A machine shop is considering combining machining and turning centers into a single MAZA, multitasking machine center. Multitasking on the machine in the machine world is the combining of processes that were traditionally processed on multiple machines onto one machine. So the ultimate goal is to turn, mill, drill, tap, bore, and finish the part in a single setup. So the total investment cost is worth 1.8 million with the following anticipated cost savings. So now you already know that the cost of the investment is around 1.8 million. It is necessary to determine how long you can expect to reap your benefit from the investment. So most machine shops typically use 7 years and assume a 20% residual value at the end of the project life. And it is very common for a learning curve to take place in operating a complex machine. What does learning curve mean? That means that on the first year, when they are currently learning the process, they cannot target 100% na efficiency rating. So as time goes by, when your learning curve takes in, your efficiency grows up. So details on the cost of the machine improvement. So comes with the cost of investment. Here comes the cost savings. So to allow for learning curve, assume that only 50% of the full potential savings of 908,000 occur during the first year and 75% on the second year and full 100% potential from years 3 up to 7. So here is your breakdown for the cost savings. If you look at it, the current cost of the company is for the setup is around 335,000. But using the machine, it will be reduced by about 70%. So therefore, the savings is around 234,500 in terms of cost savings. Okay. So all in all, if you look at it, you have a total cost savings of 908,050 cents. Now, what should we do? Using the present worth method, consider the multitasking machine center investment project. So required initial investment is 1.8 million and the project cash flows over a 7-year project of the service life are as follows. Also, the MARR or the minimum attractive rate of return that is requested by the company is about 15%. Salvage value at the end of 7 years is 20% of the initial capital of 1.8 million. So that's your end of year savings per year. First year, since it's only 50% of the 908.50, so that means that this is only 50%. Second year, this is only 75%, and this is 100% up to the year 7. That's 100%. What does that mean? So we can now proceed to your cash inflows and outflows. To start off, let's have your cash outflow. So basically, the capital investment for the improvement project is about 1.8 million at year 0. You can see it on your cash flow provided in the diagram. So that's your investment. Second, you'll have to get your cash inflows, or what we call as savings. No? This is your savings. So the total for year 7 refers to 908,050 plus 360, because your 360,000 is the salvage value, wherein it will be cash in on your 7th year. That would sum up to 1.268 million. Okay, I'll proceed. So knowing that our cash outflow is 1.8 million and your cash inflow is at equivalent to the savings plus the salvage value. So net cash flow is equal to present worth of the savings minus the present worth of your investments. So when you say present worth, it refers to all of the values at year 0. So net cash flow is equal to the present worth of cash inflow minus the present worth of your cash outflow. Now, we can proceed already in solving your provided equations. Number 1, you have at the end of year 1, you have 454,000. Looking at the present value from a certain future of 454,000 at 15% interest rate on 1 year. Since it is at the end of 1 year, so you need to get its present worth at year 0. The 681,000 is equal to, or the factor is P of F 15% and 2, because you'll have to get its present value at year 0. Succeedingly, your 908,000 is on year 3, and this is an annuity, and this is your year 7. So you have an annuity of 4 years. Okay, this is an annuity of 4 years at 15%, and then you get the present worth value on it on its second year, since the present worth value that you will be able to get here is at the end of year 2. So you'll have to get it, or to convert it into year 0. Lastly, your 1.268 million would be P of F slash 15%, 2, and minus $1.8 million. So for your 1,268,050 P of F 15%, this is 7. Okay. Now you have your cash inflows. This is the total cash inflows, or your cost savings minus the cash outflow. As you can see, your 1.8 million does not have to be converted into the present worth, because that's already at your year 0. So present worth is equal to 394 for the 454, 514K plus 1.960K plus 476K minus 1.800K. So that would mean that the present worth is equal to the sum of all of your cash inflows is equal to 3.346573 million minus 1.8 million. That's equivalent to 1.546. 573 million and 004. So after getting all of the net present worth, what would you have to decide after that one? So since the project results in a surplus of a positive 1.546 million $573, the project is deemed acceptable. So it is returning a profit of greater than 15%. Okay. So that ends the present worth method. I'll be presenting on the succeeding topic or the annual worth method. So annual worth method also means that it is equivalent to the annual equivalent worth or the AE criterion, provided a basis for measuring investments worth by determining equal payments on an annual basis. So you are looking into what is the equivalent annuity for all of your cash inflows and cash outflows. So knowing that any lump sum amount can be converted into a series of equal annual payments, thus you can be able to compute for the annual worth. AE is equal to the present worth multiply A over P, I, N. So that is your factor for a annuity worth using a present value. So if your annuity criterion is greater than 0, that would mean that the investment is accepted. And then if it is equal to 0, that means also that you have to remain indifferent because you do not have any income or profit based on your interest rate. So, and then if your annual worth is less than 0, you'll have to reject your investment. So assuming you have the same problem. So when it comes to the steps, the following steps 1 up to the rest of the steps or step 6 is the same as for net present worth. Okay. Still, you'll have to determine the interest rate or the MARR. Number 2, the service life of the project. Number 3, the cash inflows. Number 4, the cash outflows. And then number 5, the net cash flow for each period. Number 6, the annuity net cash flow at the MARR. And determine the annuity worth for every year. So as you can see, when it comes to your steps 1 up to step 6, those are the same. So what differs actually on the step 7? Because you'll have to determine the annual worth for the investment. So annuity worth, that is P present worth over the future value of an annuity. So as you can see, if you have the same problem, your present worth or the present worth of the investment is your 1.8 million. Succeedingly, you'll have the sets of cash inflows or cost savings. And then on the year 7, it indicates the same value of 1.268 million because you have a 20% salvage value that is considered as a cash in on your 7th year. So combining the inflows and outflows, here is the whole picture or diagram of your cash flows. Proceedingly, you'll have to compute for your annuity. So all of those cash flows, the cash in minus the cash out, our inflows and outflows should be converted into an annuity. When it comes to this type of problem, the annuity we considered is an ordinary annuity equation. Therefore, you'll have to use the ordinary annuity equation on these types of problem, not unless stated that the start of the payment it is at the beginning of the year. Now, let's compute for the MARR and the annuity worth method. So as you can see, your future worth, basically you can solve it using two ways. But let's take into consideration first the future worth. We're looking for the future. So future worth of a 454,000 is the F of P, 15% after 6 years. And then the 681,000, that is F of P, comma, 15%, comma, 5, plus the 908,050 F of A for 4 annuity payments. And then, since it's the future, you get the future of the value of an annuity here. Projecting the future value of your 4 series of annuity payments on the 7th year, this is your factor. And then, plus the 1268. So it will not have any factor since we are computing on year 7. Minus the 1.8 million, then F of P, 15% for 7 years. Therefore, as you can see when you solve it using your calculator, I'll give you some time to solve it. You can pause this video if you are currently solving. No? Now, so proceedingly, we are looking into that the future worth of your investment is equivalent to 4.1 million. Knowing that F is equal to A, 1 plus I to the exponent of n minus 1 divided by I. Therefore, we can already solve for A. Your A is equal to Fi over 1 plus I to the exponent of n minus 1. That would mean that your annuity worth is equivalent to 371,734.85. So knowing that you already know the annuity worth of the investment, what would that mean? Since the project results in an annuity worth of 371,734.85, the project is acceptable. So it is still returning the same profit or a greater profit compared to the MARR of 15%. Now, let's try to compute it using the present worth. Provided that we are computing it in your present worth, here is your table, no? So, on our first discussion on the present worth method, we already know that the present worth is around 1.5 billion. We know that the formula for a present worth of an annuity we know that the present worth for the formula of an annuity is given by the equation P is equal to A multiplied by 1 plus I to the exponent n minus 1 over I multiplied by 1 plus I to the exponent of n. Your A, therefore, is equal to 371,734 using the annuity worth from the present value. Therefore, you can be able to decide that still the project is acceptable. So if you look into it, even if I solve it using the future worth, annuity worth, or the present worth, it will give me the same decision as to accept or reject the investment since the same cash flow are provided. Now, let's discuss on the future worth. So basically, it is the future worth criterion, the future worth of all cash flows, inflows and outflows associated with the investment project. The difference between inflow and outflow is referred to as the new future worth. This determines whether the project is acceptable. So the same steps applies with your present worth and annuity worth. The only difference is on your what? The same flow, but the difference would be on your step 7. So on your step 7, you should have, if your future worth is greater than 0, that means that investment is acceptable. If it is equal to 0, you have to remain indifferent. And if it's less than 0, reject the investment because the investment gives you a lesser value than the MAR. So assuming we have the same problem actually, no? So the cash outflow is 1.8 million at year 0 and your cash inflows or the cost savings plus the salvage value in the 7th year is the same. Therefore, that on your computation, you should be consistent whether you are looking into the future, the present, or the annuity worth. Why? Because if it confuses you on what year you are looking into or what considerable interest period or payment year are you considering, you should be consistent. No? So on a table provided, you have to compute the future worth. So future worth that is 454, comma 6 since it is from year 1 up to year 7. So it compounds 6 times. With that, you can be able to know that the future worth of your investment is equivalent to 4,113,914.94. Also comes with your decision that since the project results in a surplus of 4.1 million, the project is acceptable. It is a profit, returning a profit greater than 15%. So we are already done with the first 3 topics. No? Net present worth method, annuity worth, the future worth method. Now we'll go into discussing the ROR or the rate of return using the IRR method. So what is your IRR method? Anyway, IRR. So rate of return is a negative rate of return implies that you will never recover your initial investment. Why? Because the rate of return is negative, therefore your cost outweighs your benefit. So there are actually 3 ways in solving your rate of return for any types of investment. If you do not have the interest rate provided, you do not have your MARR, so you're only given 2 or more cash flows. But since our class is more on the direct solution method and the calculator method or what we call as the trial and error, we'll have to compute for the rate of return for each project. No? So here are example problems. No? Kung yung magugtang IRR class, that is the internal rate of return. But pasabutan na niya. What is the interest within all of the cash flows if walay gihatag na MARR? So we'll have to compute for the rate of return for the 2 types of projects. Number 1, you'll have project 1. So this is the year and the cash flow. Kung mingon tag negative 3,000, this refers to a cash outflow. And when it comes to a positive 4,500, that refers to a cash inflow. So to start off, let's have our first project. So what is the IRR for the first project? Given the cash flow, you'll have to make it sure na equivalent siya to 0 first. No? So cash flow for project number 1. Your first cash out is $3,000 at year 0 and your cash inflow is 4,500 at year 4. Now, what's your rate of return or the IRR? So when you are asked on the interest rate of the rate of return, that refers to your IRR method. So the present worth is equal to negative 3,000 plus 4,500 P of F comma I comma 4. Therefore, your 3,000 is equal to 4,500 divided by 1 plus I to the exponent of 4. Now, you can be able to compute what is the value of your I. Therefore, your I is equal to 10.67%. What does that mean? It provides you the interest rate that your investment is gaining an interest rate of 10.67% per year in 4 years. Next. This is the cash flow for your project number 2. So you have the cash out or cash outflow of $2,000 on year 0 and cash inflows of 1,300 year 1 and 1,500 on year 2. So with that one, you'll have the ROR. To get the ROR, the present worth for the equation is negative 2,000 plus 1,300 P of F comma I comma 1 plus 1,500 P of F comma I comma 2. Now, you'll be able to know that the equation is equal to $2,000 or the cash inflow or outflow is equal to the cash inflows. Since we are looking for the I, therefore we'll have to multiply first all of the values to simplify that one. So by simplifying your equation, you'll be able to get 2,000 I squared plus 2,700 I minus 800. You can go into your calculator on equations. The degree is 2. You'll have to input your values. So the 2,000, which refers to I squared, that is the value of A. The 2,700, that is the value of B. And the negative 100, that is your C. Therefore, you'll be able to get two values. The first interest rate is 25% and the second interest rate is negative 160%. So since you do not have any negative value for a certain interest, so you'll have to go through the solution or the answer or the IRR for project number 2 is 25%. Comparing it on your project 1, and your project 2, comparing it, it would tell you that your project 2 has a greater internal rate of return or it gives you a greater value of interest. No, because when you look at your when you sum up the benefits, your 1,300 plus 1,500 actually that is only equivalent to 2,800. Okay. And then ang katong project number 1 4 5 man. And if you look at the monetary values, basically your project 1 is greater. But when you consider in your interest or what is actually the interest earned by your investment, you could tell that your project number 2 gains a bigger chunk of the interest at 25%. Now, I'll be discussing again the last part of the worth method. So, this is your the ROR method. So ROR method is if your ROR is greater than I, therefore that's feasible. And then your ROR, or the rate of return, is equal to the net annual profit over the first cost, or divided by your first cost. And then the net annual profit is equal to AI minus AC. AC is all of the annual expenses plus the annual depreciation charges. So say for example, we have a fixed capital investment of 10 million. Is required for a proposed manufacturing plant. And estimated annual maintenance is 10% of the fixed capital investment. Number one, determine the rate of return on the total investment if the annual revenue is 2.5 million. Letter B, determine the minimum payout period if the annual profit is 2.5 million. So by solution, ROR is equal to the net annual profit divided by your first cost. Since your net annual profit is 10 million, di ba? Minus the 10% annual maintenance cost divided by the 10 million first cost. Therefore, your rate of return for the investment on a yearly basis is 15%. Number 2, or letter B, the payout period is refers to the DN over AP. Okay, so payout period is equal to 10M minus 0, since we are considering that the salvage value is 0, divided by your annual profit of 2.5 million. Therefore, your payout period, or the return of investment of your money, is approximately 4 years. Okay, that would mean that your investment mabawi ra na nimo when it comes to your annual profit ay by the end of 4 years. So, we are already done with the discussion on the worth method. I'll be posting another video for the part 2 of module 5, which will cover the ratio, wherein you have the benefit cost ratio, profitability index, and the last part for module 5 is the break-even analysis. So kindly, we will have a live Q&A discussion also for this topic for better clarification on certain topics. Thank you and see you next time.